Dear friends, in this class, let us discuss a problem on the aircraft performance. Especially, this problem is based on the minimum drag as well as minimum power conditions. First, let us see the problem. Yeah, an aircraft weight is 250 kilonewton, has a wing loading of 80 meter square, and its drag equation CD equal to 0.016 plus 0.04 CL square. Calculate the minimum thrust required and the minimum power required for straight and level flight, and corresponding true airspeeds at sea level and at an altitude of 1000 meter. So at 1000 meter, root sigma is given as 0.58. So now let us see the given data. So given data, W equal to 250 kilonewton, and wing area is 80 meter square. CD nothing but that is a drag, okay, or drag polar equation. So generally this will be given by the aircraft manufacturer. So 0.016 plus 0.04 CL square. So at 1000 meter, so root sigma equal to 0.58. So sigma is nothing but rho by rho naught. Okay. So we will see how we can use this data. So first let us solve the problem. Before solving the problem, first let us find the conditions for the minimum drag as well as minimum power. So by using those data only, we can calculate minimum thrust required and minimum power required. So now at minimum drag, at minimum drag conditions, so what is, so at minimum drag conditions, CL minimum drag equal to square root of CD naught by K. So this is nothing but we know CD naught, okay, we know 0.016 divided by 0.04. So the value is okay, it's nothing but 0.632. This value is 0.632. Okay, then CD minimum power, minimum drag, so that is nothing but twice into CD naught. So 2 into 0.016, so 0.032. So then velocity at a minimum drag condition, so 2W by S by rho CL minimum drag. So this is square root of 2 into W. W is nothing but 250 into 1000, because it is in under root, so we have to substitute in this basic value. So the, this rho density is nothing but 1.2256. so standard sea level value into CL minimum drag 0.632. so then into 80, because 80 is the wing area. So okay, after substituting this, then we are getting the value. This value is around 89.79 meter per second. Okay, so we got the minimum drag conditions, values at minimum drag. Now let us find the values at minimum power. So at minimum power, CL minimum power, that is equal to square root of 3 CD naught by K, that is nothing but 3 into CD naught, nothing but 0.16 divided by 0.04. so this value is around 1.095. okay, 1.095. so this is the CL minimum power. Then CD minimum power, that is equal to 4 CD naught, equal to 4 into 0.016, so this is 0.064. okay, CD minimum power we got it. Then velocity minimum power, that is equal to square root of 2W by S by rho CL minimum power. So this is okay, 2 into 250, the W 250 into 1000 divided by 1.2256. this value in some books they may give it as 1.226. so if the value is given, you can take it, otherwise this I am taking the standard sea level value. so into the CL minimum power, so 1.095. Then this we have a area also, wing area, that is 80. So we just go, okay, this value, velocity minimum power, nothing but 68.24. This is after doing the calculation, 68.24 meter per second. Okay, this value we can calculate by using relationship also, because we know minimum power equal to this is 0.76 into VMD. Okay, so this, so because we know velocity at minimum drag 0.76 into 89.79. okay, so this calculating, if you are calculating this value, that value will be equal to this value. Okay, 0.76 into 89.79, that will be equal to 68.24. okay, so by using this relationship also we can find out, or okay, by using the minimum power conditions, by that we also we can find out. okay, so now we got the minimum power okay, as well as minimum drag conditions value. Now let us find the thrust required minimum and okay, power required minimum. okay, so first let us find out the thrust required minimum. So thrust required minimum, when we say thrust required minimum, means nothing but drag is minimum. okay, drag required is minimum, that is what. So thrust required minimum will be is achieved at the drag required, means because thrust is okay is equal to the drag in steady level flight. So thrust minimum, just we can just say thrust required, that is equal to drag. okay, drag, minimum drag. okay, so this is okay, we can write it as W into CD minimum drag by CL minimum drag. okay, so this is okay, so drag minimum, okay, drag that means drag at minimum drag. okay, just we are finding it by using this. So this is nothing but W 250 into 1000 into this is okay, I am writing in the basic unit, CD minimum power 0.032 by CL minimum drag. okay, CL minimum drag we have just got it 0.632. okay, so this value comes around so 12.64 or 12.65 also we can say, 12.65 kilonewton. okay, so just okay, so one thing we have to note down, thrust, okay, minimum thrust required. okay, minimum thrust required is okay, achieved at the minimum drag conditions, and also this value will be constant okay, at every altitude. okay, because at each and every altitude this thrust required minimum or drag, okay, minimum drag, okay, so that will not be changing, because for finding the thrust required minimum we are using this formula. So in this formula what happened, we don't have any parameters which reflects the variation of the altitude. okay, so generally variation of the altitude is just used to be represented by using the density. So there is no any parameter okay of density so to represent the altitude. So we don't have any okay, so density variation. So because the thrust required will this will be minimum. okay, this one will be the same at every altitude, that is what we have to understand. So even this is at the sea level, and this is at the sea level, it is okay, it is at the sea level. So it is not only at sea level, also at 1000 meter, at 1000 meter altitude also the thrust required minimum is the same. This is what the same value. okay, so that is what we have to understand. So I think now let us go to the minimum power conditions. So yeah, minimum power required. Minimum power required, okay, just we are calculating by using this. okay, so P minimum is equal to, means drag minimum power into velocity minimum power. okay, So because this is drag minimum power we have to use. So okay, this is drag minimum power. Similar way we can use CD minimum power by CL minimum power. Then okay, into velocity minimum power. So okay, substituting values for this, so we will get the W is nothing but we can just find 250 into 1000 into CD minimum power. CD minimum power we know 0.064 divided by CL minimum power also we know 1.095 into velocity minimum power. Velocity minimum power we have seen, that is nothing but 68.24. So this is 68.24. Okay, so this value okay comes around that means 999. Okay, we can 999. Okay, not 999, 997 or 997.15 into 10 to the power of 3. Okay, 10 to the power of 3 kilojoule per second. Okay, so that is nothing or kilowatt. So then this we can write it as this one. We can write it in terms of this kilowatt, nothing but 999. Or if you want to write in terms of megawatt also we can write. So 997 point 15 kilowatt or 0.997, that is megawatt. Okay, or 0.997 megawatt. Okay, so this is a value for okay minimum power required. Okay, power required minimum at a sea level. At a sea level, okay, we are just doing it. So at what happened at an altitude of 1000 meter, what happened, this velocity will have the variation. Okay, velocity will have a higher value, okay, different value. Because of that reason, power required minimum at 1000 meter will be different. For that only we are using this variation of density. Okay, that parameter is represented by root sigma. So that root sigma we are using. Okay, so because the root, why we are using the root sigma, that is also very clear, because root sigma comes that means sigma is nothing but rho by rho naught. Okay, so this is what. Okay, so root sigma generally we are using because velocity we know, velocity generally we used to write. Okay, this is a formula, rho CL. Okay, so this rho, okay, at sea level, at if it is okay sea level and 1000 meter, so the only this is okay. Suppose this is at a sea level, so sea level, let us say this one, then velocity at 1000 meter, so will be square root of 2w by s by rho 1000, okay, into CL. Okay, so in this by comparing okay velocity at the sea level, velocity at 1000 meter, the variation is only in the density. Okay, because the rest of the parameter everything will be same, this parameter and this parameter, everything is same okay at every altitude, only these are varying. So because of that reason only, just rho by rho, okay, this one rho by rho naught. Okay, so rho naught, suppose if you take it as the sea level density, this is the sea level density, then this is okay, so this is what rho by rho naught, so this is what we say sigma. So why do we take it as root sigma? Because of the square root. Okay, square root is there in the velocity. Okay, so because of that reason. Okay, so now if you want to find out, already we have seen the thrust required minimum is same okay at every altitude. Okay, so there will not be any change, that value remains constant. Okay, so whereas power required minimum is okay, will be different. So at sea level we have seen, at power required minimum at sea level. Okay, so at 1000 meter, okay, what is the power required? Okay, power required minimum, so this is okay. So power required minimum, okay, at 1000 meter, so nothing but power minimum at sea level whole divided by root sigma. Okay, So if you are just substituting this, and then we will get, because power required minimum we all know, that is nothing but we got, okay. So W into CD minimum power by CL minimum power into velocity minimum power. So this velocity minimum power will be different, okay. Velocity minimum power at 1000 meter, okay, we can just say. So at 1000 meter, okay, at 1000 meter velocity minimum power is nothing but, so velocity minimum power at sea level square, okay, this is root sigma, okay. So if you are just doing it, then we will get, okay, because velocity minimum power at okay, sea level is nothing but 68.224. So divided by root sigma, this is, okay, root sigma nothing but 0.58. So this value, comes around 117.66 meter per second, okay. So velocity minimum power, okay, at 1000 meter, okay. So this is velocity minimum power at 1000 meter. Similarly, we can find out the power required minimum at 1000 meter. So that is nothing but we can just power required minimum at sea level nothing but 0.99, okay, 7 megawatt, okay. So into 10 to the power of 6 by root sigma 0.58. So this value, okay, will be something around 1.712 megawatt, okay. So power required minimum at 1000 meter, this is, okay, at 1000 meter. This is also, this value also at 1000 meter velocity, okay. That means power required minimum power, okay, velocity at minimum power, that is 117.66. Similarly, we can, if you want, we can find out the minimum drag, okay, minimum drag velocity. So that also we can find out, okay. So minimum drag velocity minimum drag at 1000 meter is nothing but velocity minimum drag at sea level, this is sea level, by root sigma. So velocity at minimum, okay, this is, we know, okay, how much it is. So this value it can be calculated, okay, substituting this value. So 89.79 divided by roots 0.58. By doing so, you will get the velocity minimum, okay, velocity at a minimum drag, okay. So by this way we can find out the thrust required minimum and power required minimum at sea level, and also at an altitude of 1000 meter.